Hey, what's up guys, welcome back to another tutorial about visual effects in Unity. My name is Gabriel Guiar and today we are going to see something really cool, something about destroying objects. That's right, we are going to see how to shatter some objects and create some visual effects to make it look even nicer. And I have already destroyed some objects to show that this free method with Blender is really easy and can be applied to pretty much any object. This scene is available on my Patreon in case you are interested in supporting me, which will also give you access to some really cool game effects packages. So let's see how you can fracture pretty much any object yourself. So once you have your object in Unity, you only need to add a rigid body and save it as a prefab. Now, to fracture objects, we need to go to this site or to this site. Both links are in the description, where you can download Blender Fracture modifier, created by Martin Felk. You can download for Windows, for Linux or for Mac. Once you have installed this build, you can open it and make sure it's the branch Fracture modifier, as you can see. Let's select everything with A and press delete. Now let's go up here to File and select Import FBX. And as far as I know, FBX is the type that works best, but obviously you can try other formats. So let's go to the folder where you have your object, and since I have the chest already fractured, I'm going to fracture a box for ammo, just to show that this works with pretty much any object. Now I'm going to select Ammo Box FBX and press Import. Alright, cool. So as you can see in this case, it's only one object, which is okay, no problem with that. But if we try to fracture this object, we would have a lot of problems. What we want to do is to separate into smaller objects. And Blender has a great tool for that, which is the L key. But first let's enter in edit mode with Tab. And now we can use the L key to select completed meshes. And as you can see, if I press L, it only selects the box. And the hinges and bracelets will stay behind. And now we can press P to separate the selection we have. Cool. And we actually want to do this to every object that we want to separate. In my case, I'm going to separate pretty much every object, as you can see. So I'm using L to select and then pressing P to separate into a new object. Alright, cool. Once you have done that, we can go back to object mode with Tab. We want to select the box and then press Ctrl I to select the inverse, which will allow us to press H and hide the hinges and the bracelets. And this will facilitate our breakdown process. Alright, so with the object we want to break, we can go to the Physics button, the last one, and press Fracture. Once we have done that, you will notice that we have plenty of options, but let me make this easy for you by closing the Fracture constraint settings, as well as the Fracture animated mesh settings. We don't need that for now. As you can see, in the Fracture settings, we have presets, we have Fracture mode, we have Fracture algorithm, and how many shards we want our object to have. And I'm going to say 15, you can put more or less, it's up to you, and we can already press the button Execute Fracture. Once you press Execute Fracture, it seems like nothing has happened, but if you press Z to see in a wireframe mode, you will notice that we have a lot of objects. But there is a small problem. If we zoom in, we can see that the Fracture algorithm has filled our fractured objects. And we actually don't want that. We want this to be empty. We just want to shatter the object. We don't want any fill. And we can fix that by going to the Fracture algorithm and select Voronoi plus Bisect. Now let's press again Execute Fracture, and this time if we press Z to see in wireframe mode, we will notice that it has only fractured our objects without filling them, which is awesome. But this is still only one object. That's no problem at all, because if we come down here, we will have a little button that says Convert to Objects. Cool! Now we have all the fractured objects separated from the main box, and we still have the main box, which you can double click and press delete. We don't need the main box, we only need the fractured objects. And we only need to do one last thing, because if we zoom in now, you will notice that it seems like it's double-sided. but if we turn on backface cooling, we can see that it isn't double-sided. And if we try to explode this in Unity, it would look really weird, because all the fragments would only have one face. So we need to make these fragments double-sided. And the way to do it is by selecting one of the fragments, go to the modifier panel and add a solidify modifier, which will basically add some thickness to our fragment. And since I don't want to generate too much faces, and I only want to make this double-sided, we can set 0 in thickness and it will solve our problem. Now, to apply this modifier to all the other fragments, we can select them all and press Ctrl L, which will create a link between all the fragments and the last selected object, which in this case it's the fragment with the solidify modifier. And we can make a link with modifiers, just like this. And now if I go in here, you will notice that every fragment is double-sided. Great! Now let's press Alt H to unhide the hinges, and we can select everything with A or with B, and go to File, select Export and choose FBX. Make sure to turn on selected objects and to click in this button to fix the scale and select Mesh. Now you can export this to any folder you want. In my case I'm going to export it directly into Unity. Great! Now back to Unity, we can drag and drop our object that we have just fractured, and I'm going to fix the scale. I want this to be a little bit bigger so I can show you how this works. And now as you can see we have all the fragments that we have generated in Blender, but they don't have any material. So we can select them all and we can drag and drop the original material of our object. Just like this. It will automatically apply the material and the UVs are still correct, which is really great. Now with all fragments selected, we want to add a mesh collider and we want to turn on convex, just like this. And lastly, we want to add a rigid body and make sure the mass is between 0.2, 0.3, which should be enough for each fragment. Alright, so let's go ahead and create the script so we can explode our object. It's going to be a very simple script which we can name to explode tooth script. Let's open it up, and we don't need update nor start for now. And we need the public float, which is going to be the minimum force, and the public float with the maximum force, and then a radius of action, basically. And now we want to create a function called explode, which returns void and it's public. So this script is going to be attached to our fractured object, which means we can do the following. We can iterate through each fragment with a for each that checks every transform t that is in transform. We are going to cache the rigid body of each fragment to a variable. And then we say if the rigid body is different than null, we can actually use the add explosion force function from the rigid body. This function asks for a float, and we can use random branch between minimum force and maximum force, which means the force is going to be randomized between each fragment. It's going to look more unique. The position of the explosion, it's going to be the transform.position, and we are going to pass in the radius, which we have just declared. Oh, and let's create the start function so we can test our explode function. Alright, so let's add this to our fractured object. In my case, the minimum force it's going to be 125 and the maximum force it's going to be 750 and the radius 10, and these values are probably high. I suggest you try it out to see which one fits best in your case. Alright, let's press play, and as you can see it works really well and creates a nice explosion where we have fragments that go really far away, other fragments that doesn't go that far, which is awesome, but the fragments will stay there forever basically. And to make this simple, we are going to simply destroy the fragments after 5 seconds. And destroy delay, it's going to be a public float with the same name. Alright, 5 in the inspector, then destroy delay. And after 5 seconds it destroys the fragments. Cool. The next step is to create a very simple script so we can switch our original object with the one that is fractured. So let's create a script, call it brown fractured tooth script, and I'm going to attach it to my scene. You can attach it to other objects if you want. This is only to show you how you can use this in your game. And now I'm going to delete our fractured prefab and drag my original box without being fractured. So let's open up the script, and we don't need the start function, but we want a public game object which is going to be the original object, and then a public game object for the fractured object. And basically in the update we want to check if we press mouse button 1, which in this case is 0, and if we pressed, we want to call a function called spawn fractured object, which we will create down here. It's going to return void, and as soon as we call this function we destroy our original object and we instantiate our fractured object into a new game object, just like this. And you can use this in many ways, of course, and it's going to be as game object. With this new game object we want to get component explode tutorial script and access the explode function, just like this. So as you can see, it's really simple, nothing special. And in my inspector I'm gonna drag my ammo box to original object, and I'm going to drag the fractured version of my ammo box prefab to the script, just like this. You can press play, and now as soon as you click it will create the sensation that you are basically exploding that box. Alright, so that was just to show you how you can create that illusion. And now we can spice this up by creating an explosion effect, a really simple explosion effect. So let's create an empty, rename it to explosion tutorial, and inside it I want to create a particle system which I'm going to rename to beam. And the beam is basically going to be a flash of light which will not loop, and the start lifetime is going to be 0.3, and the start size it's going to be 8, probably even more. And in the emission we don't want any rate over time because we want a burst with 10 particle systems, but our maximum particles will only be 1, which means you can always increase the intensity of this flash of light. We don't need any shape either, and the size over lifetime will have a curve similar to this one. And we want also some color over lifetime, which will be from full opacity to no opacity at all, just like this. Great. And for the start color I'm going to choose an orange, just like this one. This is supposed to be a flash of light, so the start lifetime it has to be a little bit smaller, 0.2, and it also needs to be a bigger flash of light, 15 in this case. Alright, let's duplicate this beam and rename it to shockwave. And in shockwave we want to go down here to the renderer and set the render mode to horizontal billboard. And this time, in the size over lifetime, we want a curve that goes from small to big. The color over lifetime is fine, and we may need the start size to be bigger, 20, 25, maybe it's too much, we will see in just a few moments. Because now we are going to open Photoshop or your image editing software to create a quick texture, which is going to be called circle. It's going to have a width and a height of 500 pixels. Let's paint the background to black, and with the shape tool we want to create an ellipse, which we can hold Ctrl Alt Shift to create a proportional circle, just like this. Let me just make the circle white. And now we want to align it with V, which means we can choose the ellipse and the background, and with V we can press these icons right here, which will align to the center of our image. Awesome. Now we don't need any fill, and the stroke is going to be white with 0.1, real small, because we want to double click in our ellipse and choose outer glow. And in outer glow we want to increase the size and then the spread. Alright, so the size is really big, maybe around 70 for the size and a spread of 11, even more, it's up to you. You can press OK. With Ctrl T I'm gonna make it smaller, just like this, so it fits in the image. And we are almost done, we just want to set the fill to around 30. And now if we zoom in it looks really cool, really smooth, really nice. Let's hide the black background and export this as a PNG to Unity. Once in Unity, we want to create a material, call it circle in this case, and change the shader to particles additive. And let's drag and drop the texture that we have created to the texture slot. And now we can drop the material to our shockwave. Cool. So shockwave is acting really weird, and this happens because the max particle size has to be bigger, around 3 should be enough. And now we have a really big and really slow shockwave. So let's set the start size to 15 and the start lifetime to 0.3 or 0.2, it's up to you. Cool, that's looking nice. Now let's create a new particle system, which is going to be for our smoke. And for the sake of this tutorial, we are actually going to use some Google images. Yeah, we are going to search for smoke PNG, and you can choose one similar to this. Of course, this is just for educational purpose, don't forget that. And you can import that smoke PNG to Unity. You can duplicate the circle, rename it to smoke, and drag and drop our smoke texture, and then drop the material to our smoke particle system. So in my case, the start size is going to be between 1 and 3. Start rotation is going to be random between 360 and minus 360 because it gives a lot more possibilities and it's much more random. And randomized rotation is going to be 1 as well. Start lifetime, it's going to be between 0.5 and 1. 1.2 it's too much, I think. And start speed is going to be between 0.5 and 2.5. The shape is a sphere, and rate over time it's going to be 0 because we are going to use a burst between 20 and 30. Let's go down here, turn on color over lifetime, and we want full opacity to no opacity gradient. We also want a rotation over lifetime between minus 45 and 35. Cool, nice. Now let's make the color random between a light orange with low alpha, with low opacity, and a darker orange with low opacity as well, something like this. Alright, it's looking great, real simple explosion. And let's just add a little touch by creating some particles now, some small particles. And we can duplicate the beam, parent to our beam, and we are going to rename it to particles and remove the child, just like this. And the particles will have a start lifetime between 0.5 and 1.2 and a start speed of 0.5, 8, probably 10 more, it's up to you. The start size is also going to be really small and maximum of 0.3. You can make it random between two colors like this, and our count is going to be between 20 and 30. And we are going to use a sphere for shape. Oh, and let's just increase the maximum particles to around 50 so we can see some particles in action. Alright, it's looking interesting. You can use the gravity modifier if you want, it will give a nice touch. Cool. Alright, so our explosion is done and it's looking really cool, really simple, really nice. Let's go create a prefab from this explosion. We can delete the one in the scene. And let's go over to our explode tutorial script, and we want to create a public game object which will be the explosion, and then we want to create a public vector tree which will be the offset explosion or explosion offset. And now every time this explode function is called, we want to check if the explosion is different than null. If it is, then we want to create a new game object which will be equal to instantiate open brackets as game object. Let's give it the explosion game object. The position is going to be transform dot position plus our explosion offset, which will be ND, and it's going to be quaternion dot identity. Alright, and we are going to simply destroy our explosion after 5 seconds, just in case Unity doesn't destroy it. The start, we can remove it, we don't need that, and let's press save. Go to the inspector. Go to the inspector of our fractured objects, and let's drag and drop the explosion we have just created. And I know my explosion offset has to be 1.5 in the Y, otherwise the explosion looks like it's in the middle of the ground. Anyway, let's press play and see how this is looking. Alright, it's looking cool, I really like it. It's not bad for a simple explosion. You can improve this a lot. For example, we can give it a quick touch by creating a smoke trail that will follow the debris. And we can easily do it by going to the explosion that we have created and duplicate the smoke particle system. And unparent from the explosion. Delete the explosion, create an empty, rename it and parent the smoke to that empty. And for example, it can have a duration of 4 seconds. The start speed can be between 0.5 and 2. I will fix it in a moment. The start size can be a little bit smaller, 0.7, 2. And what's important is that we change our emission. For example, we want 25 in the rate over time and we don't want any burst. We don't need it. You can turn off shape, just like this, alright. I'm going to increase the start speed, like I said before. The size over lifetime is also going to be the opposite, actually. Something similar to this. Alright, cool. And what really matters is that the simulation space is set to world, so it can leave a trail of smoke behind. And now we can create a prefab of this smoke. Let's go over to our explode script and add a public game object called smoke and a public integer called maximum smoke. We want to create a smoke counter in the explode function, and in the for each we want to say that if smoke is different than null and smoke counter is less than maximum smokes, then we want to create a game object called smokefx, which is going to be equal to instantiate as game object, and we are going to pass in the smoke and it's going to be parented to the debris, which is t.transform. Cool. Next thing, we can destroy the smoke effects after, let's say, 5 seconds. But if we leave it like this, all the smokes are going to be instantiated in the first few debris that it finds. And we want to create some randomness and instantiate in different debris, not the first debris. So we can do it by saying that if random.range is equal 1, we can say that random range is between 1 and 4. Every time it's 1, we want to spawn a smoke effect in that debris. This way it will create some randomness. And now we want to increase the smoke counter, ++, just like this. Back to our inspector. After compiling, we want to go to our fractured object and add the smoke that we have just created, like this, and I'm going to say maximum of 10 smokes for now. So let's test this out by pressing play. And as you can see, it looks a little bit more interesting. Of course you can play around with smoke, you can even create flames, you can do plenty of cool stuff. It's up to your imagination. So that's basically it for this tutorial, guys. I hope you have really enjoyed it. I want to say a big thank you to all my patrons that supported me in the last month. You guys rock and are awesome. These videos wouldn't be possible without you. And if you are not supporting me, and if you can, I would appreciate a lot, and you will get access to some really cool FX packages. So that's it, guys. I hope you have enjoyed. Thanks for watching. See you in the next video.